Alright, so this is section 7.1, which is on first order systems and applications. So let's recall what a differential equation looks like. So differential equation looks like, for example, x double prime minus 4x prime plus 3x equal to sine 3t, for example. So the differential equations we've seen before usually only have one function to solve. And now we're going to introduce something new, which is called a first order system. Okay, it's a system, so that means there's more than one equation in a system. So that's, for example, you can have a system of two equations. X prime is 2x plus 3y, and y prime is x minus 3y plus sine t. So usually there's multiple functions to solve. But because it's first order, so it only involves the first derivatives. So there's pros and cons on each side. For differential equation, the pros is that we only have one function to solve, but the equation might involve higher derivatives, which is sometimes can be complicated. For first order systems, it's the opposite. The pro is it only involves the first derivative, but you have multiple functions to solve, so it may be more complicated. But the good thing is these two things can usually be converted into each other. So having one is pretty much the same as having the other one. All right. So let's first learn how to convert a differential equation into a first order system. All right. So let's directly do an example. So let's suppose we have a differential equation, x third derivative plus 3x second derivative plus 2x prime minus 5x equals to sine 2t. So the conversion goes as follows, because the trick is because it involves the third derivative, so we know there's going to be three equations in the first order system. So we're going to introduce three new functions, x1, x2, and x3. So x1, just let x1 equal to x, and x2 equal to x prime, and x3 equals to x double prime. Because x1 is x, then x2 is x prime, then x2 is automatically x1 prime. And similarly, because x2 is x prime, x3 is x double prime, so x3 is x2 prime. So this tells you that x1 prime is x2, x2 prime is x3, and the last equation comes from the original equation, so let's do that. Okay, so the third derivative of x is x3 prime plus 3 times x double prime, that's x3, plus 2x prime, that's x2, minus 5x, that's x1, equal to sine 2t, which means x3 prime equals to 5x1 minus 2x2 minus 3x3 plus sine 2t. So this is a first order system after conversion. All right, so let's do a different example. The conversion is pretty much similar. So suppose we already have a second order system. Let's say we have 2x double prime equals to negative 6x plus 2y, and y double prime equal to 2x minus 2y plus 40 sine 3t. This is a book example. So this is a second order system. But we don't want a second order system. We want to convert into a first order system. So what's going to happen is you look at the original equation, x double prime is involved. So we want to introduce two new x's. We want to introduce x1 and x2. x1 is x, x2 is x prime, which is x1 prime. And same thing with y. So y double prime is involved, so we let y1 equal to y, y2 equal to y prime, which is y1 prime. Okay, so here we have one of the equations. X1 prime is equal to x2, and y1 prime is equal to y2. Now let's look at the original equation. So this one tells you that 2 x double prime is x2 prime. So x2 prime equal to -6, x is x1, y is y1. So we get this equation. So let me copy that down here. 2x2 prime. Let's divide by 2 on both sides to make it look prettier. So x2 prime is -3x1 plus y1. Same thing with this. You can just put it here. So y double prime is y2 prime and equal to 2. X is x1 to y1 plus 40 sine 3t. So now this is a first order system after conversion.